In this lesson, you'll learn how to interpret the duration cost scatter plot, also known as the joint confidence level chart. This plot helps you visualize in a single diagram the relationship between two of the most critical variables in any project, the project's completion date and its total cost. What does the scatter plot show? The plot compares two variables. On the x-axis, the horizontal, the project completion date or duration. On the y-axis, the vertical, the project total cost. This chart allows us to analyze how both variables behave simultaneously, which is essential for effective risk management. There's four possible scenarios. When analyzing the scatter plot, the simulation results fall into four possible quadrants. Total success, on time and under budget. Cost overrun, on time, over budget. Delay controlled, late but under budget, and worst case, late and over budget. The scatter sheet displays this chart with the data points generated by each iteration. 5,000 iterations. Each dot represents a possible project scenario based on completion date and cost. These data points are compared against two reference values found in cell B5 and B6 in the parameters sheet. B5 contains the target completion date, and B6, the target budget. By default, these values correspond to a deterministic original scenario. For example, July 25th, 2026 as the expected finish date and $23,000 as the baseline budget. Each of the 5,000 data points will fall into one of four quadrants. So an example of simulated scenario distribution: on time and under budget, 14%, on time and over budget, 10%, late and under budget, 9%, and late and over budget, 68%. This tells us that in this case, more than 2/3 of the time, the project ends up late and over budget. What does this mean? This shows that the deterministic scenario, July 25th, 2026, and $23,000, is too optimistic. In real life, it is unlikely to happen due to the uncertainty in task durations and costs. Conclusion: we need more realistic targets. A common strategy is to use the 80th percentile to set targets with a higher chance of success. So, under the suggested new targets, completion date is going to be July 31st, 2026, the 80th percentile, and the budget, 24,680, the 80th percentile. These values are entered in cells B5 and B6 in the parameters sheet. After applying the new goals and updating the chart, the probability of success meeting both targets, time and cost, increases to 68% probability of success. This means that if we use more realistic percentiles 2 out of 3 times, the project will succeed. Now, why isn't it exactly 80%? Even though both values, time and cost, are set at the 80th percentile, the combined probability drops to 68% because it's harder to meet two conditions simultaneously. The combined probability reflects the conditional intersection of two events. So we conclude, using the scatter plot and adjusting goals with percentiles allows us to visually understand project risks, set more realistic expectations, and make better informed decisions. We haven't yet incorporated external risks into this simulation, but even so, this shows how probabilistic analysis dramatically changes the probability of success of the project.